Alright, so we're still back to recording in 420 instead of 444, so do let me know if it makes any noticeable difference in to what you see compared to the videos that I've done over the past 3 months. It's a lot easier to record this way, it takes up less disk space, I can directly import it into Vegas, and it's just easier for me all around. I feel like I've been going a little nuts with this channel. Is archiving in 444 for the shit that I'm doing seriously actually needed? So just let me know. I'm going to let the users decide. If you think that it's different, then let me know. So I want to go back into talking about what I talked about in one of my previous videos. I got a lot of comments on this that I thought were worth bringing up. It was about brain off versus brain on mode, and I was talking about how I don't... And some people were saying, you know, you always say use your brain. You're always saying use your brain, so what do you mean brain off? Well, what I mean by brain off, brain on mode is that there are times where you can fix a problem without having to think, where you can just rummage through something and just pretty much, you know, act like a monkey and just swap things, and you wind up fixing a problem. So what I mean by brain off mode is this. So let's say this has no backlight, right? No backlight. Now, I'm not even going to turn on the multimeter. I'm not going to measure anything. And I go over here. Right? And I see this. Now, I know that that's the backlight enable voltage divider, but I'm not, to be honest with you, I'm not even going to bother looking that up. Like, if I were new, I wouldn't even bother looking it up. I would just be in my brain off mode and realize that that looks kind of screwed up. Now, the reason that I like to do this brain off, brain on thing is because, as I've said in many of these videos, I'm the only person here that's doing all of these repairs. So it's really easy to get burned out. And a lot of people have said, you're going to get burned out if you keep doing it. And the way that I'm able to do all these jobs for you know, other service centers, for myself, for customers who walk in, for customers who mail in, for recycling companies, the way I'm able to get it done without burning out is by saving my brain. And the way I save my brain is I simply don't turn it on. I think through things in a logical fashion, but there are times when I simply don't have to think. Water fell on this part of the machine. Therefore, there's going to be some funny business on that part of the machine. You know, just no need to think. Just look. And looking really just does it. Now, if something doesn't work afterwards, then I have to engage brains. But I don't have to engage brains in the beginning, and not engaging my brain before it's absolutely time to is really helpful for me because it allows me to save my brain for when I need it and allows me to not get burned out. Because it would be easy to get burned out. Again, you know, my last vacation, I define a vacation as where it's like more than a day off at a time or half a day off or something like that. It was March 2014, right? So, you know, you kind of start making worse decisions. You start making worse decisions. You start not caring as much when you get burned out and all that. So it's important. Oh, it's so blurry when you zoom in. This is another tip for people who want to get this type of equipment. Everybody likes the microscopes with the big zoom, right? You know, having a lot of zoom. But here's the thing. You see when I move the board how it goes out of focus, in focus, out of focus, in focus, out of focus, in focus? I'm barely flexing it. Now, when you zoom all the way out, right? When I zoom all the way out and then I put it in focus, I can move the thing around a lot and it's still in focus. So you notice that? The more zoomed out you are, the more space you get. The more wiggle room you have before you go out of focus. Whereas if I go all the way up to 45x, and I get it in focus, okay, it's in focus now, but literally I tap the desk and I'm out of focus. So this is why I use my microscope at maybe, 7x, maybe 10 most of the time. I don't go nuts trying to find the perfect level of zoom. I spend most of my time at a low zoom, because it allows it to stay in focus, which causes less fatigue. And that's another thing, is getting fatigued. You know, I can't afford to get fatigued. I don't have an assistant I can hand this shit off to. Nor do I have the luxury of understanding customers. Flow back into place, mofo. I'm gonna have to go over that again. That's some shit solder joint. We'll go over them again once they're at least rested on the board here. I decided to get rid of that split screen view. In most of my videos, you can't actually see what I look like while I solder. And I had it set up with that split screen thing so that you could see. I originally set that up just so that while I'm measuring in the multimeter, you could see the board and the multimeter at the same time. And for some reason, I left that as a scene in Open Broadcaster. And yesterday, I was using it, and I got this huge stream of comments like, "Oh my God, you have Parkinson's? Are you dying? Blah blah blah," because people saw the extent to which, you know, what I look like while I'm working. And then I started getting some bullshit ones like, you know, I wouldn't trust a guy to work on stuff if he looks like that. He probably screws stuff up all the time. And it's like, yeah. It's one of those things where it's like, the more you know, the more you control. So, yeah, I learned that it's that's the thing. Like, if people see what I do under the microscope, they're like, wow, that's great. Yet, if I show you that exact same work under the microscope, but then you get to see what the person looks like while they're doing it, it turns into, oh, look, he's screwing everything up. It's interesting how that works out. So again, if you see because in that video, the funny thing is, here's the funny thing. In the video that I did that I'm talking about, the results were actually better than what I usually get. Like, everything was soldered into place where it literally looked factory. After I would have cleaned that board, obviously the fucking thing didn't work, but after cleaning it, it would have looked factory, even if it worked like shit. So, but it looked great. But nobody focused on that. What people were focusing on was my arm movements as I was working, and since they were focused on my arm movements as I was working, and yes, yeah, I do this with the tweezers sometimes, or I use my left hand instead of my right or whatever, they thought that the exact same level of work was then shit. And I thought that was pretty interesting. And it's one of those things where I genuinely understand. I kind of get it now, because I used to have, I used to have it on my web. There's a lot of stuff on my website I've changed over the years, but one of the things that I talked about is I do all of this stuff within view of the customer. That was obviously before I had all this rework equipment. This was like a really long time ago. And a lot of people are like, I don't understand how you do things in front of customers. That's insane. Because the thing is, you can do the exact same level of work, but when people see how you're doing it, they lose their shit. I'm not saying people in the YouTube comments were losing their shit, but there were a fair amount of comments on there. And then I remember just getting down to one is like, wow, I'm surprised that the guy's not screwing things up with the way his hand tremors and blah. And it's like, yeah, if only you knew. I have lines of shit here and in the front of the store. I have shit from school districts. I have shit from recycling companies. I got like 5 local stores in the neighborhood that bring all their stuff here. And these are the hands that get the job done. And I like my hands. Show me a light. Show me the light. Oh, this is a 2013 Air. Notice that I'm purposely using the hand that I never touched the solder or flux to wipe my eye. I always keep track of those things. Somebody did ask in another video, if you wear gloves, why do you wipe your eyes with them? So, this is the 2013 Air, which means it's going to turn off and on and off and on and off and on. And then finally boot. You can do it. Did you boot, mofo? Wah, wah, wah. Oh, fuck. Okay, time to turn the fucking brain on. Okay. So, we're going to go over to the backlight circuit. Let's go over to the backlight area. In the schematic diagram. First thing I'm going to check is backlight output over here. Output at the ends of the boost circuit. If you don't know how a DC to DC boost circuit works, I made a long video on that. It has pictures and everything. So backlight output is measuring 19. So here's the thing. This is supposed to be about 24, 25 volts. Now, different numbers on output are going to tell me different things. So if I have, let's say, 50 volts on output, that's going to tell me that it can't see the backlight, meaning that somebody opened the case and tried to replace their screen and is lying to me about the fact that they plugged the flex cable upside down. Or the LCD cable is bad. But 99% of the time, it's the first one. You remember how the phones used to work a long time ago? Like the voltages on the phone line used to actually let the phone company know, or I forget how this worked. Like, not like I worked with, fucking rotary dial phones, but the voltages on the phone line let them know, or allowed you to tell whether or not the phone was on the hook or not. So if you had a load, you would see maybe 5 volts, whereas if there was no load or the phone was off the hook, you would see something like 49 or 51 volts. The same is true here. So if this backlight circuit is trying to make a certain voltage, it is trying to make a certain voltage with a specific load, meaning the load of the LED strip of the lights, it'll make its way to 25 volts when you plug the lights in. However, if it's trying to make that same voltage but there's no load, the light is not plugged in, then you're going to see something like 49 or 50. So I know it's seeing the load. It sees a load because, it's not going ridiculously high. It's not going to 49 or 50 volts. I also know it's boosting. This boost circuit over here is taking 8.4 volts. So PP Bush G3 Hot is over here is taking 8.4 volts, and it's sending it through and trying to make it into something high. So I know that the circuit has the capability to do boosting. So I know that and the other thing that I'm told by the fact that I see 19 volts up here is that there's no break in the line. There's no break between here and here. The diode is good. There's no break between here and here. The inductor is good. The transistor is good. I know that there's no break in the line. If I saw 1 volt up here, then I'd have to kind of start searching back and forth to figure out where the break in the line occurs. Now, what else is there that I can... Okay, so what I'm going to look for now I know backlight enable is most likely going to be good. I'm going to look and see what the PWM voltage is. Now, what the PWM is going to do, PWM is going to set brightness, and that's one of the things that you can tell if you just Google the name of the chip. You Google LP8550, and you'll get a data sheet that tells you all these things. Texas Instruments, they're nice people. They're not douchebags like Apple. They release data sheets to their products that anybody can Google and find on Texas Instruments' own website. I'm surprised that Apple uses Texas Instruments for anything, since Texas Instruments doesn't do the shit that they do with the intersil chips. With the intersil chips, the ones that are used for, let's say, charging, yeah, good luck finding a data sheet to this fucking thing. Good luck, good luck. I wish you the best of luck. I wrote a nice diagram, published an older video on the exact sequence of what has to go into this, what's going to go out of it, and what. And that is something that you just got to guess over a long period of time, because there is no data sheet to that chip, because Apple doesn't want Intersil releasing data sheets to chips that they use in their machine. And that's the other thing that I get here a lot. I get a lot of people saying, oh, Lewis, it's proprietary. They shouldn't have to release proprietary data. Then people are going to create knockoffs. Yeah, you're right. Other companies shouldn't know how to charge a battery. Imagine if other companies could create a product with a battery that could be charged. Wait, are you telling me that we could just create an 18-volt, $20 power source and put a $10 battery in the computer and have this chip regulate whether or not you use the charger or the battery? No. Only Apple should be able to get the fuck out of here with that shit. Like, the people who make those kind of comments, they really have no idea what's going on in the world. Like, newsflash. People have been creating laptops with batteries for like 30 fucking years now. It is... it's like almost 30 probably. It's like, get the fuck out of here with that shit. You have to be so fucking brainwashed to seriously believe that there is any benefit to the world, any benefits of patent, trademark, copyright, in any way, shape, or form to not release the data sheet to an ISL 6259. Like, it's just one of those things, man. It's like, other companies know how to create laptops that charge a battery. Okay, so let's see. Backlight enable voltage is... Yay, 2.8. PWM is... 0. Oh, are we seriously where we were with that other fucking video? Tell me SMC lid is missing on this too. Tell me SMC lid is missing on this the same way it was in my last... It's not. SMC lid is a straight up Measuring the right. Yeah, so SMC lid is indeed where it's supposed to be. So SMC lid is the signal that is going to tell the machine that it's open. Now, if that signal is low in voltage, it's going to assume that you've closed the computer, and it's going to do what a closed computer does, which is turn off the lights of the screen. Makes enough sense, right? I'm just going to make sure that I was indeed measuring the right section there, since you never know, I could have been doing something stupid just then and measuring a different signal, since I wasn't in the microscope. So I'm going to go back and measure SMC lid once more. SMC lid. I'm supposed to be getting a straight up 3.42 volts in SMC lid. And I get 3. Yeah, that's perfect. So now let's go back and measure enable and PWM. So let's just go back to the sheet over here. Now it's being told to turn on, right? I'm going to check V in, so I'm going to check that this chip over here is receiving power on voltage in, meaning it is being told, it is being powered. This is the chip that's going to control boosting. And I check PWM. I'm going to check that. And after I confirm that PWM is there, okay, let's see. Let's see, what do I get? PWM is 0.066. So it's there, but it's low. Now this is one of those things that I'm kind of wondering. Is PWM low because it's not being sent, or is PWM low because this backlight chip is shorting it to ground because it's screwed up? Now here's the thing. SMC lid is high, meaning that the computer knows that the backlight should be on. It's not like it's telling it to be off. The thing that sends out the PWM signal is the CPU. So if the CPU is bad, I'm not replacing that because it has, like 900 tiny balls under it. I have to buy it for over $100. The LED driver is something I can replace in, it's a matter of a minute, and it costs me about $1.89. So it's worth it to me when I'm going through what my different guesses are. I'm going to start with the guesses that make the most economical sense, the stuff that I can actually reasonably do. So I'm just going to take that LED drive. And also I can assume that there may be a problem with the driver because that other chip, the other resistor around it got burned. So let's go down a little here. And take this thing off. Took a little longer to take off than usual, which is actually a hint that the LED driver itself may have a problem. May have been burned on the board or something. Okay, so first things first. I'll remove this. Just gonna go over this area and with some leaded solder because that makes it easier to remove the lead-free solder that's on the board. I'm gonna wick this. I'm not gonna put that on top of the old solder that's there. That would be mean. I would only do that if this is somebody where I needed it done absolutely immediately and they were calling 50 times in a row. It's one of those things that happens all the time. It's like I'm working on something. I'm debating whether or not to do it properly or not. And then I get a phone call going, why the fuck isn't this done yet? And then it's like, yeah, I'm not wicking the old pets. I'm not. Yeah, that's where I usually draw the line. If I've been cursed at on the phone, then wicking the old pads is something that I'm not really going to do. But I usually try to do things the right way the first time. Like, I try. But I give up as soon as I realize that me trying to do something right the first time is not valued by the other person. There's also a missing resistor there for F-set. What if that was the problem, not the LED driver? See this? I forget if that's I-set or F-set, but that's not there. That should be. You could also see that I accidentally wicked some solder off there. Oh well. What are you gonna do? I'll re-add it to everything. Okay, get some flux on there. Get my driver chip. Let's see if I can kill several birds with one stone here. Okay, I am going to try to put the resistor and the LED driver on at the same time. I'm kind of getting greedy. Wouldn't it be funny if that was it and it wasn't the driver the whole time? I just wasted $1.89 on this fucking piece of shit for no reason. That's the kind of money that you just can't get. You gotta think about these things. I wasted $1.89. Ugh. Come on off. Come on. Okay. Now what I'm going to do here is I'm going to wait for the flux to kind of go away. A lot of people start from really far away and then they go really close really quick. And then the flux starts acting up and doing crazy shit. I don't want that to happen. I wait for the flux to slowly heat away. And I move in this little motion where I'm just kind of encouraging it to move around the board. And I wait for there to be only like about a millimeter of flux outside each side of the chips that I'm working on. And then I go in close. And by then, I don't have to worry about things flying away. And we're almost to that point. See on the LED driver, okay, the flux has finally gone away. Now I can go in close on the LED driver. Poke my resistor into place. The resistor is going to melt before the LED driver because the LED driver is lead-free solder, whereas the resistor is leaded. Okay. Something tells me I screwed up on soldering the LED driver. It's actually a really simple job. It's hard to screw that up unless you're a total idiot. Which would explain why I managed to screw it up. Let's see. Or did it just sink into place really well? Did I do such a perfect job that I couldn't see it move into place? Or did I do a completely asinine bullet BS job? Yeah, it could stand to be moved over to the right a little bit. Oh, no wonder. I had the air almost all the way down in the hot air station. Of course, wasn't paying attention. And I had the heat pretty low on this, so no wonder it wasn't really melting the lead-free solder. I should have paid more attention to that. What you want to do is you want to make the chip dance. See that? See how the chip is kind of moving back and forth with me? That's how you know that all the balls are melted, and that's also how you know that the chip is going to naturally adjust itself into exactly where it's supposed to be. You want the chip to adjust itself to be exactly where it's supposed to be. So it's not like you're putting it down straight. You just want to get it down so it's flat enough on the pads that it's not going to blow away or that it's not going to go to a pad that it's not supposed to. That means that it's not going to get soldered on pads it's not supposed to. But if you have the proper amount of flux under there and some good stuff, then it's going to move itself into place just fine. Just a little bit of alcohol to clean that area and cool it off. After this, it'll wind up going in the ultrasonic cleaner 60 Celsius, Branson EC, and distilled water for about a minute. After that, it'll go in a bath of alcohol, and after that, it'll go into the air filter to get rid of the alcohol, and then it'll go in the oven at about 250 Fahrenheit. Not for reflowing reasons, just to get rid of any residual alcohol that may be stuck. And then the board winds up looking really clean in that case. And once it looks nice and clean, I can reassemble it. Unless they call 50 times, in which case it'll get given back to them with globs of flux on it. A lot of people ask, like, do you give stuff back to people with flux on it? I don't know. How many times did they call? You know? I will always go above and beyond to do as good a job as humanly possible when people let me. Okay. I like giving back boards that look factory. Stuff that looks nice. That's not that bright. That's really not that bright. I'm going to get trolled as to whether or not I fix this, aren't I? Okay. All right, let's plug in the rest of everything so that I can put the brightness setting up. Okay, shut you down. Yeah. I'm going to get trolled hardcore. Okay, we're going to wait for it to boot. I didn't plug in the light sensor either, which is why it doesn't know how bright it should be. Once it boots, I'll put up the brightness in the operating system and you'll be able to see that it worked. I was wondering why my comment stream has been blowing up recently, and it looks like I hit Reddit again. Like front page of Reddit again. It's pretty cool. I can always tell when I've hit the front page of a website because it's a mixture of a bunch of really happy, kind, nice posts with a bunch of kill yourself, kill yourself, kill yourself, kill yourself. Is this guy a cross between a nigger and a Jew? I can always tell which comments are the ones from 4chan, because all the ones that are from 4chan are the ones where it's like, are you a cross between a nigger and a Jew? That's the reason that I kind of stopped like using 4chan a lot. I mean, I used to go to 4chan a lot when, like, long time ago, like 13, 14 years ago when I was younger. Here we go. I'm just going to cover the name. You can see the light. But yeah, you can see the light. I mean, almost every single thread that I would read on 4chan, like, the thing is with 4chan is you have a lot of stuff that's genuinely interesting, like thought-provoking, insightful, a perspective that you're only going to read there that you're never going to read on another website on the planet. And then you have, like, at the end of the thread, that person is a cross between a nigger and a Jew. And I'm not trying to use the words in an offensive sense. It's just like, these are the quotes. And it's like, it's just, the reason I'm laughing is it's like literally, it's like 10 years later. 10 years later, and that trend continues on. I think it's 4chan. What are you going to do? Anyway, so that's it for today. As always, I hope you learned something. Thanks for watching, and that's it until next time.